The example on the first page of lesson 26, which is also giving us another rational equation that we need to solve. And I'm going to illustrate the same point that I was trying to make when I did the first exercise. And that is, if I can make these denominators equal, in other words, if I can find a common denominator and rewrite this equation so that the left and the right-hand side have the same denominator, then I can set the numerators equal to each other and use and solve for x in that way. So, of course, you've already noticed that 12 is a perfectly good common denominator between 12 and 6. So I will leave my left-hand side as it is, and I will multiply the top and bottom of the right-hand side so that I end up with a 12 on the bottom, the denominator. And so now, once again, if I have two fractions that are equal and their denominators are equal, then their numerators must also be equal. So right from here, I can simply say x plus 3 is equal to 10. And for this simple example, really, I've used the properties of equality here. I can multiply both sides of this equation by 12, and then those 12s would divide out on either side, and I would just be left with this equation. And that's simple enough to solve. X equals 7. But again, the point that we're really trying to make with this problem that's going to come in handy later is if I can get the bottoms or the denominators of the left and right side of this equation to be equal, then I can simply set the numerators equal to each other and solve that more simple.